A little review of Environmental Controls 1 for the fall 2019 semester. We took over the coursework of Sue Akiyama, and in my section we incorporated a lot of BIM projects, and but still adhering to all of the course content that Sue had laid out. So we ran the Tuesday, Thursday series with an in-class lecture on Tuesdays, and then an online lab on Thursdays, where there were videos prepared outlining course material that we discussed in a lecture the previous Tuesday, and students worked through this on their own, basically signing in to the Blackboard Collaborate software so they could ask questions and share information. This is one of the first projects we did. It was based on some the initial discussions of lighting in the lecture. We used Revit to create a BIM model of an office space where we incorporated two different kinds of windows and then did some lighting analysis studies of it. At this point, looking back on it, I think the building that we started to construct was way too complex. We included some concepts of light shelves to see if we could get different rendering properties, and just really testing out whether BIM would work well for these kind of analysis. And we had both good and bad results from that we took forward on other projects. We moved into ideas of insulation and heat loss in the lab that week. We did energy calculations on a building, and this is the build-up of a wall of a small mock-up assembly where we created the walls, calculated R values using spreadsheets, and then we ran two analyses using an average window style and then an enhanced window style to come up with different heat loss calculations. And we used the heating degree days from the site wherever we picked it, and we got this online through source degreesdays.net. And we did a cost comparison then of the difference between a better performing window and a poor performing window and how much money that would save. So we could start to do get a little idea of cost justifications and the effects of window glazing systems on total heat loss with buildings. Back to HVAC systems, we presented ductwork, all kinds of issues about heating and ventilation in this lecture. And then in the BIM model we constructed, we took our existing building, we added steel structure to it, placed a rooftop unit, added some extra steel to support that, and ran ductwork through one section of the facility in order to get a feeling for placing these components and then the visual appearances of them. And this is probably not the best example of this project, but in some cases we actually ran an alternative where we stripped out the diffusers and put them in the other ductwork and did a visual comparison with that. With plumbing, we covered all the ideas of fixtures, drain, vent lines, and that. And our first project coming off of that was to look at creating an ADA accessible bathroom. So we also incorporated some discussions about ADA accessibility standards while we were placing fixtures. And we used all of the code requirements in order to lay out a two-stall bathroom configuration. And I believe this is the first time that I asked students to start making commentary. So in a lot of the slides going forward, you'll see there's an additional commentary that the students make about the project, what they thought of it, what they learned from it. And I found this was very effective, and next year I would incorporate that if I was redoing this course for all of the projects. But here BIM modeling, really giving them an idea of how to do the detailed drawings, the call-outs, all of the necessary things to take care of the one of the basic tasks of creating an ADA accessible bathroom. And once we'd created that bathroom, to further extend our work with plumbing, we routed plumbing to all of the fixtures and vent lines. We installed a point-of-use hot water system and routed hot and cold water plumbing to it. This helps students deal with the idea of venting, especially with ideas of ceilings that don't go all the way to the top roof deck. So they had a chance to get a feeling of what plumbing layouts look like. We introduced in the next module, we introduced electricity and started to look at some of the code issues with things like kitchens and bathrooms. And we extended our model, our ADA bathroom now, to include a little food prep area if it was a commercial facility, and the placement of fixtures along or outlets along the countertops with the code compliant spacing requirements. We placed an electrical panel in with enough spacing to meet code for accessibility around it. In a little appliance closet that we created, we installed lighting and a switch circuit and made a wiring diagram for that, and once again added commentary by the students, which I found quite successful. We had some, I believe, weeks where we didn't have lectures, but I still had a lab time. So I inserted another analysis project, where in this case we took a generic model. This is the first time I moved into simplifying the overall concept of the modeling we would do. So that big office building we started with, I simplified it down to what would be like a visitor center. We modeled that, and then we used ComFen, which is a U.S. Department of Energy's software that allows us to, it's commercial fenestration, and it allows us to analyze the heating gain and heat loss of a facade, a glass facade. You can configure the facade, then place it in two different locations and get two different outputs of total energy requirements for those facades. And then we can compare two locations with the same facade to look at heat loss and heat gain. And once again, some commentary on that. So in a lot of these now, we're starting to do the idea of A/B comparisons. If I was to go back here, we did energy window analysis, looking at two different window systems. And in this case, we're introducing an analysis of two different locations for a building, an identical building and its performance in another site. We've already started to discuss in lectures ideas of insulation systems and heat loss. And then we further move that along with a heat loss analysis using the internal tools within Revit and a external product that Revit has called Insight. So the idea here, we're moving towards high performance building envelopes. So we do a construction baseline to code. We send it out to, we make an analytical model and send that out to Insight. And we get data back describing its energy performance. And then we look at enhancing the energy performance of that BIM model, running it through Insight again, and seeing how we can improve the performance of that. And there were some issues with that. Insight's not well integrated with Revit as far as round tripping. We had to do a lot of modifications, but for the most part, I think it was a good learning example. We had a section on acoustics, and we played that out in our visitor center again by placing all kinds of acoustical interventions, the construction of a wall assembly with a high STC between the bathrooms and the common area. We applied ceiling acoustic tiles, decorative. We applied wall panels to surfaces, and we included things like furniture that had high sound absorbency. So this gave them a chance to practice the idea of doing these interventions. In this case, this is a clipping of a gypsum board construction with a rated STC performance, and then the actual section of that wall that we created between the bathrooms. In renewables, our project was to actually place photovoltaics up on the roof, and we looked at various configurations for the performance of them. We have a flat roof. We put flat panels on. They didn't have optimum orientation, so we did an analysis where we used software that would allow us to generate the output of the panels, and then compare what we were assuming the costs be, and then looking at simple payback based on the amount of energy they produced. We then tilted those for better performance to shorten payback. But when we tilted those, we realized we had to make space or reduce the amount of panel count. So we had less cost in the panels, but less power output. And then finally, we altered the roof configuration so it's fully tilted, so we can put a maximum number of panels on. And in this case, we get the lowest amount of, or the shortest payback period. And once again, a writing of a narrative of the students' work on that. Vertical transportation, we look at elevator systems and discuss the types of elevators, escalator systems, and in this case, this was a way to reinforce those discussions. We grabbed a BIM model of an elevator, inserted it into a core that we constructed on a multi-floor setup, and created an escalator, took in an escalator BIM model and placed that on the scene, helping students to deal with the requirements of spacing, the people flow around it, just general ideas about these cores becoming structural elements within the buildings. This was a place to start pulling some of our discussions about site and energy. We now knew about building orientation. We'd started to look at now issues of selecting a site, placing our visitor center on that site. We modified the topography so that we could create a collection pond, a detention or a retention pond, using runoffs from our roof systems and our parking systems. We incorporated porous pavers. And we imported a windrows from a site that gives us windrows for geographical locations. And then we oriented our landscaping in order to create windbreaks advantageous to blocking the high winds that might be occurring on the site. So this just helped them to localize all the issues that might be happening. And we also built a north arrow that could be inserted right into the model so that no matter what the model view orientation, there's a way of always visualizing which way north is in the scene. And once again, the idea of the narrative, really strong feedback from students as to what they were learning and what problems they were having. Students do a field trip to the Net Zero house. They are very enthusiastic about it. They seem to enjoy it, feel like it's a very worthwhile task. I asked them to report in a Google Slides, give a screenshot. I wasn't able to attend. Professor Ebert was graciously took over those tasks for me. And I asked them to do a screenshot and add it to a Google slide, selecting themselves in the scene and then, as a selfie, and then something that they thought was the most important or interesting component of their visit to the site. And the final thing to wrap it up, we did a green roof. And mostly here is just to introduce the idea of the requirements of introducing these kind of interventions, these natural, sustainable interventions into real-world construction. So here we do a BIM construction section of a structural deck on a truss system that we insert to create a beefy roof assembly, and then we create the all of the details needed to build up a simple green roof system. Then start to deal with the idea of edge treatment and other things that would go around that. So that's quite a few projects, I think, for the introductory course. I think they get a lot of experiences that they can carry forward into their studio work as a basis for their studio work. And in the performance of the students, we have a span from 120 points of completion, at least at this point. We've got a little more to go on the semester yet, one more week, and then students usually will fill in the blanks of some things they've gotten behind on. But I have a high level of completion by all of the students, except for a few. One was struggling with BIM modeling, and just a few of them are just more troublesome as far as getting work done. So I hope that gives you a general overview of the project and what kind of environmental controls looks like for going forward, and maybe we can transfer some of these ideas into the mainstream program. Thank you.